Hi guys, welcome back to Worms Maths Academy. Right now we're going to be going through some more anti-diff. In this case we're looking at, basically it's the inverse of the chain rule. So we're going backwards. I'll just refresh you. If you have a function like y is equal to 2x minus 3 to the power of 6. When we differentiate that, we use the chain rule. We bring our 6 down to the front, multiply it by the derivative of the bracket, which is 2, multiply it by the bracket, and then take 1 away from the power. So we end up with 12, 2x minus 3 to the power of 5. Now we have a rule when we have a bracket with a linear equation inside to a power, how to anti-diff it. So this rule says if I've got something like 12, 2x minus 3 to the power of 5 dx, if I have ax plus b, it's 1 on, so in this case it's going to be 12 because I've got a 12 out the front, on a, and a is the coefficient of x, which is 2, times our new power, n plus 1. So our new power is going to be 6. Then it's the bracket to the power of n plus 1 plus c. And you can see from here, 12 on 12, they cancel each other out. So we end up with 2x minus 3 to the 6 plus c. So that's our inverse rule for the chain rule. I'll basically explain why I'm saying the inverse. If we have the integral of 12, 2x minus 3 to the 5 dx, when we apply the chain rule, we bring our power down to the front, we multiply it by the derivative, and then we take 1 away from the power. Well, if we're going to do the inverse, first we have to add 1 to the power. Then, instead of multiplying the power down the front, we've got to divide down the front. Before we multiplied it by our derivative, now we've got to divide it by our derivative. And we also had that 12 on top, plus c. You can see there they cancel out. So we get 2x minus 3 to the 6 plus c. Now this formula is on your formula sheet, so you don't have to stress too much about trying to remember it. So this one here, we're going to get 1 over the derivative of the bracket, which is 2, times our new power, which is 4, 2x minus 1 to the power of 4, plus c. So we have 1 on 8, 2x minus 1 to the power of 4, plus c. This second one here, we have 1 on my new power multiplied by my derivative of the bracket, so 3 times negative 1, 3x minus 2 to the negative 1 plus c, which is negative 1 on 3x minus 2 to the power of negative 1 plus c. So all I did was put that on the bottom because it's a negative power. To do it on your calculator, it's just a matter of putting it in. You don't need to put anything in those terminals, and it'll give you your answer. Okay, now this is probably the most possibly confusing thing in the course. If you've got, when we derive logs, like if I had y equals log e 5x plus 3, dy dx is the derivative of the bracket, which is 5, over the bracket which is 5x plus 3. Now, if we want to use the inverse for this, the thing is with this here, if I've got 5 on 5x plus 3, let's sketch it on our CAS. So 5 divided by 5x plus 3. We've got a graph that exists on both sides, right? So the asymptote would be at -3/5. But we can find the area here and we can find the area here. However, if we were to use the same rule we did before, where we just use the inverse, we would assume that this, when I integrate this, if I said the integral of 5 on 5x plus 3 dx, because the derivative is, when I derive log e 5x plus 3, I get 5 on 5x plus 3. We should integrate that, and we should get log e of 5x plus 3, and then plus c. However, you could see from here, if I have log e 5x plus 3, that's just a graph that looks like this. So there's my curve, but it doesn't enable me to find the area under the curve for the other side. So it's basically just forgotten about. That's because when we integrate this function, we end up with two curves, two separate curves, which are, if x is greater than 2/3 and x is less than 2/3, we have two different functions. So the first one, if the top is the derivative of the bottom, so if I derive the bottom here, I get 3. Now the top's not 3, but we could make it 3. The way that we do that is we say 2 on 3x minus 2 dx is equal to, I'm going to bring the 2 out the front as a constant. I'm going to put a 3 on top, so the top is the derivative of the bottom. But because I've added a 3 on top, I've got to put a 3 on the bottom, which gives us 2/3 log e 3x minus 2 plus c. Now, if x is greater than 2/3, just say x is 1. If we let x equal 1, that's going to be 1, and log e of 1 is 0. So we can evaluate it. So that's okay. That's our answer for our integral of 2 on 3x minus 2, 2/3 log e 3x minus 2 plus c. However, if we were to put -2/3, if we were to put something less than 2/3, like 0, into this equation, we're going to get log e of -2, which we know we can't log negatives. So what we do is we say the integral of 2 on 3x minus 2 dx is equal to 2 on 3, just like we did before, 3 on 3x minus 2 dx, which we know is 2/3 log e 3x minus 2 plus c. However, if we want to use x as less than 2/3, we want to make this positive. So what we do is we put a negative out the front, and then we say out here, x is less than 2/3. And what that in effect does, if I say 2/3 log e, I'm going to get 2 minus 3x. Basically, it reflects it in the line x equals 2/3. So it's like in the y-axis, but this is in the line x equals 2/3. And we will get the left-hand side of the graph. So I'll show you what I mean. If I was to put the integral of this, so if I was to say log e 5x plus 3, we get the right-hand side. But then if we make it negative 5x plus 3, we get the left-hand side. So we've got the area. So the integral for this function here is the green graph. The integral for this bit here is the red graph. So we've got two separate integrals, and we did that by making this negative and leaving that as positive. So it allows us to find the area under the curve using these integrals. So if it makes the bracket equal a negative value, you basically put a negative outside and then multiply it in, and then that'll give you a positive value. Like it'll make it, instead of making it negative, it makes it positive. Okay, so here I've got dy dx equals 3 on x. So if dy dx is equal to 3 on x, y is equal to the integral of 3 on x dx, which we know is 3, 1 on x dx. The top is the derivative of the bottom, so we get y is equal to 3 log e x plus c. X is greater than 0, so we know we can use just this x value here. And when y equals 10, when x equals 1. So 1, 10 gives 10 is equal to 3 log e of 1 plus c. Log e of 1 we know is 0, so we get c is equal to 10. So y is equal to 3 log e x plus 10. X is greater than 0. Next, if x is less than 0, we basically have the same thing. And y is equal to 10. We get the same equation, so y equals 3 log e x plus c. But we know if x is negative, which is less than 0, it means that it's negative. Then we've got to say 3 log e negative x, because when we sub negative 1 in, negative 1 becomes 1, and we can evaluate log of 1. But you can't evaluate log of negative 1. So that's why we have to put that negative x in there, and we say x is less than 0. So from here, we know that negative 1 goes through 10. So we get 10 equals 3 log e 1 plus c. That's 0, so c equals 10. So our equation is y equals 3 log e negative x plus 10. X is less than 0. So in doing this, what we can do is basically create one equation. We split it apart when the solution to the bottom is greater than 0. So when the bottom is greater than 0, we just use ax plus b. And when the bottom is negative, we use negative ax plus b. So what I mean, let's just do this question here again. But we'll do it giving one equation. So the significant part is 2/3, but if we didn't know, we would say the integral of 3x minus 2 dx is equal to 2/3 3 on 3x minus 2 dx. Our integral is split into 2/3 log e. Now the significant part, like the part where we decide which one we use, or which way we go, we say 3x minus 2 is greater than 0. 3x is greater than 2. X is greater than 2/3. So this one will be 3x minus 2 for x plus c. for x is greater than 2/3. And then for x is less than 2/3, we say 2/3 log e, and then we change the sign of everything inside. So we get 2 minus 3x plus c. So that's our answer when we integrate this function. We get two separate functions, one for when x is positive and then one for when x is negative on the bottom. Okay. Now, there's another way to do this. Special kids would do it this way, because there's a function that we learn in specialists that we used to learn in methods. They don't really do it anymore. Well, it's not part of the course. And that function's called modulus. And that means the size of, or the magnitude, or basically make inside positive. So what we do, instead of splitting into two functions, we put these magnitude signs around the function. And then you can use whatever you want. So for instance here, if I have 5 on 5x plus 3, the top is the derivative of the bottom. If we were to say that when I integrate it, I get log e, and then we said mod 5x plus 3, that gives us both the left and right hand side. So it does it both without having to split it into two functions. Because what it does, when you put a negative number in here, it evaluates the inside and then it makes it positive. So if I had, I'll show you here, let's do an example. So if I have the integral of 2 on 3x minus 2 dx, we get 2/3 3 on 3x minus 2 dx, which we say is equal to 2/3 log e mod 3x minus 2 plus c. Now, if we use the same example before, when x equals 1, y equals 10, we get 10 is equal to 2/3 log e modulus signs. If I substitute that into there, I'm going to get 3 minus 2, which is 1, plus c, so we can evaluate that, it's just 0. C equals 10. If we have when x equals negative 1, we get, well, they wouldn't say the same thing actually. They wouldn't say when x equals negative 1, y equals 10, because it's going to have to equal something different. Because if we put negative 1 into that, we would end up with negative 5, and log of 5 is not, it's not 0. It's not 0, like log of 1 is 0. So if we put a negative 1 into that, we'd get negative 5. The magnitude of negative 5 is log e of 5. Yeah, that makes sense as well. Because if you have a function like this, that is a bit strange. Okay, it's a very different function. That's why it's not going to work, because it's not symmetric. That's my fault. Okay, if we did it for this other function over here, we would get y is equal to log e mod x plus c. And we know when, so this is this function here, when x equals 1, y equals 10, so we get 10 equals log e of 1 plus c, so c equals 10. when x equals -1, y equals 10. Therefore, 10 is equal to log e, the magnitude of -1 plus c. Now, the magnitude of -1 is just 1. So basically, we're saying log of 1, which you also know is 0. So we get c equals 10. So here, whenever you get a number, you evaluate what's inside the bracket. If it's positive, it's just that number. If it's negative, you just make it positive. And I've got an example here. So, it's the same bloody question. I just did this. Okay, so dy dx is 3 on x. Therefore, y is the integral of 3 on x dx, which is 3 log e mod x plus c. When x equals 1, y equals 10. So we get 10 is equal to 3 log e of mod of 1 plus c. That's 0, so c equals 10. So we get y equals 3 log e of mod x plus 10. From here, we get dy dx is 3 on x. Y is the integral of 3 on x dx. Y is equal to 3 log e mod x plus c. And when x equals -1, y equals 10. So we get 10 is equal to 3 log e mod of -1 plus c. That's 0. So we get c is equal to 10. Y equals 3 log e mod x plus 10. So either way, you get exactly the same function. Before here, we didn't get initial conditions with this function. So that's why when I substituted 1 and 10 in, that was for this function. That's why it didn't work. But it will always work if they give you initial conditions. If you use modulus, which is what I would do, just because it's so much easier. Like, it makes sense if when we get this function here, if I anti-diff it, it makes sense to have the solution, the integral of 2 on 3x minus 2 dx is equal to 2/3 the integral of 3 on 3x minus 2 dx. We know that we can say that that's 2/3 log e mod 3x minus 2 plus c. And then we say x is an element of all reals with the exception of it can't be 2/3 because you can't log 0. But other than that, you can use any value, negative or positive, and it'll evaluate to be positive because whenever you evaluate it, you'll get the answer, you'll turn it into a positive value because of the modulus signs, and then you'll get the actual correct answer. So you can definitely use modulus signs. They are really, really useful because they allow you to find areas under the graph easily as well. I will show you that more in a later video, but hopefully this has helped with integrating functions where the top is the derivative of the bottom. So it's going to be a log as top is derivative of the bottom. In specialists, you do this all the time, but in methods, it's always going to be like a linear function, like 3x minus 4 dx, and you could have something like 6 on top. When I derive the bottom, I don't get 6, I get 3. So what we can do is we can put a 3 on top and put a 2 out the front. The top is now the derivative of the bottom. 2 times 3 is still 6. So my answer is 2 log e mod 3x minus 4 plus c. That's a perfectly acceptable solution. Hope this has made sense. It can be quite confusing, especially because they've taken modulus out of the course. So you have to either separate it apart into two equations, or you can just put a mod sign and x can't equal whatever makes that bracket equal 0. Okay, I'll see you again soon. Hope it's helped. Bye.